Hello everyone, my name is Håkon, and today I'll present our paper, Realistic Full-Body Anonymization with Surface-Guided GANs. In this paper, we propose a novel GAN for synthesizing realistic human figures for anonymization purposes. The main motivation for our work is collecting images for computer vision development, where anonymization is required to comply with regulations in many regions. For example, following the GDPR in the European Union. Traditional image anonymization degrades the quality of the data, often making it unusable for computer vision development. Instead, realistic image anonymization can retain the image quality while preserving privacy. Previous work has focused on face anonymization, however, this often leaves the body recognizable through other means than the face. In this paper, we focus on the full-body anonymization task. In the wild, full-body synthesis is a very challenging and underexplored task. Previous work has focused on simpler tasks, such as training on structured datasets, transferring garments, or changing the pose or motion of an individual. The majority of these methods disregard the background, which significantly simplifies the task. This makes these methods inadequate for in-the-wild anonymization. Our main contribution is surface-guided GANs, which conditions the adversarial game on surface information. In our case, the surface information is the output of a continuous surface embedding network, which maps each pixel to a position on a 3D human body. Our experiments are based on a new subset of the COCO dataset, which consists of a large diversity of identities in different conditions. We found that regular GANs, without surface guidance, struggled to generate coherent textures. Including surface information in the input of the generator substantially improves image quality. However, this model often struggles to generate realistic textures for highly detailed areas. For example, the face or fingers, which you can notice in these images. We addressed this issue with a novel adaptive normalization layer. Adaptive normalization conditions the generator by scaling and shifting every feature map given the condition. Smebye and StyleGAN are two common examples of this. In the figure, you see our UNet architecture with StyleGAN modulation, where the mapping network F depends on the Latin code. We propose Variational Surface-Adaptive Modulation, where we introduce surface information in the start of the mapping network together with the Latin code. This enables the GAN to directly map the Latin code to relevant locations in the image. For example, it can map the attribute red shirt to the upper body independent on the upper body's position in the image. These images compares VSAM to our baseline and the semantic counterpart Smebye. Notice the improved quality, especially in the regions including the face and fingers. We show that VSAM improves the generated image quality, diversity, latent disentanglement, and we show that it's invariant to affine image plane transforms. These are some of the synthesized results from our method. Notice that our GAN generates diverse anonymizations that blend perfectly in with the background. We recommend you to check out our paper to see more generated examples. Finally, we show that VSAM improves synthesis consistency between poses on the deep fashion dataset. If you want to find out more, please check out our open source code or come by our poster. Thank you for your attention.